this is the digestive system, and the digestive system is going to be responsible for ingestion of food and liquids. We take it in or ingest it. It's going to be responsible for digestion, breaking down of this food that we take in, absorbing it after the food is broken down. We absorb the nutrients, the protein, carbohydrates, fats, vitamins, minerals, and water that these foodstuffs give us. And then finally, what can't be used by the body is eliminated. And so it all starts in our oral cavity. Now, my real rudimentary diagram here shows the nasal cavity. Of course, if you're a little kid, you can ingest your peas through your nose, for example, because ultimately the nasal cavity is going to join with the oral cavity and form the nasopharynx and the oropharynx. And together, they're going to come together to form the esophagus. Now, most of our intake, our ingestion, is obviously going to come in through the oral cavity. And in the oral cavity, we have our teeth, which are going to help break off small pieces of the food. Okay, our front teeth, our incisors, they're going to cut the food away, so to say, and then the teeth in the back are the molars. They're going to grind the food up. In our oral cavity, we also have the tongue. The tongue is going to be responsible for moving the food around and mixing it with saliva, which makes the food more liquidy and easier to slide down our oral pharynx and the esophagus. But also, our saliva contains an enzyme called amylase. Amylase breaks down carbohydrates. So in the oral cavity, our teeth break the food down after initially cutting off a piece. It mixes in the oral cavity with the saliva by our tongue moving the food around, and then ultimately it's going to go down the esophagus. Now, we also have the tube that leads into our lungs in this same general region. Our nasopharynx and oropharynx can also take in atmospheric air and exhale carbon dioxide through a passage that leads into the lungs, the trachea. So we have a structure called the epiglottis that keeps food routed down the esophagus and air routed down the trachea. Okay, so that keeps the two from mixing together. We don't want food getting into our lungs. We also don't want air getting into our stomach. But once the food is broken down, as much as it can be in the oral cavity, mixed with the enzyme amylase, it's going to go down the esophagus. And at this point, we don't call it food, we call it a bolus. Okay, because it's all mixed up now with saliva, it's broken into small pieces, and then ultimately it's going to go through a structure right here called the lower esophageal sphincter. The lower esophageal sphincter is going to keep the contents of the stomach in the stomach and not allow backwash. And the main reason why is because in the stomach has hydrochloric acid and other enzymes which further break our food down. And this bolus, once it starts getting the enzymes and hydrochloric acid churning in the stomach to make it break down even farther, we don't want that washing back up our esophagus. If it does happen, we call that heartburn. Okay, the acidic contents of the stomach going up the esophagus, we call that heartburn. On the other hand, if it's something that occurs all the time, that's where we would get into what's known as gastroesophageal reflux disorder. That acidic content of the stomach constantly washing back up the esophagus starts to erode the esophagus, and ultimately that can lead to a host of conditions and affect our digestive system negatively. But once the bolus gets through the lower esophageal sphincter, it's going to make its way into the stomach, And the stomach has all sorts of folds in it called rugae, and that increases the surface area that this bolus of food comes into contact with, and therefore the hydrochloric acid and enzymes in the stomach have a greater amount of space to come into contact with the little particles of this bolus. And that ultimately helps ensure that the food is broken down and we can start to get the nutrients from it: protein, carbohydrates, fats, vitamins, minerals, and water, the 6 major nutrients, and now absorb those nutrients. And absorption is going to occur in the intestines. So when the bolus leaves the stomach, it's going to go into the small intestine. And this curly Q here is the small intestine. Now, the small intestine is going to be made up of 3 parts. The first part is the duodenum, then the jejunum, and then finally the last part is the ileum. The ileum is going to come into contact with the first structure of the large intestine called the cecum. We can see this little structure dangling off of the cecum. That's our appendix. Okay? And of course, this is going to be the large intestine. Now, we call it the small intestine and the large intestine because of the diameter. The small intestine, there's about 23 feet of coiled up small intestine in our abdominal cavity, but the diameter is not that great. On the other hand, the large intestine, there's about 7 feet of large intestine, but the diameter is bigger. Now, we keep moving all of this bolus through our digestive system by what's known as peristalsis. Peristalsis are muscular actions performed by smooth muscle throughout the entire length of the intestines. And for lack of a better way to put it, if you've ever started at the end of a toothpaste tube and squeezed the toothpaste forward out the opening at the end of the tube, that's how peristalsis works. Rings of muscle, smooth muscle in this case, around the intestines squeeze and it moves the food stuff forward just a little bit, and then another ring of muscle contracts that pushes it forward just a little bit, and ultimately all the way through the small intestine and the large intestine. Inside our small intestine, we have all of these finger-like projections called villi, so that way it doesn't just go right through the 23 feet of small intestine. It has to go in all of these little nooks and crannies around all these little finger-like projections called the villi, and that greatly aids absorption. It slows down how quickly this material can move through the small intestine, and by this time that bolus is so broken down and so mixed up with enzymes and the hydrochloric acid that we now call it chyme. And chyme is a soup-like material that now, because of its liquid form, is absorbed by those villi because the villi are very rich in vascularity. These vessels aid absorption. And so this aid in absorption greatly increases the surface area, therefore greatly increasing absorption and getting these nutrients into our bloodstream where they can be carried throughout the entire body and utilized where necessary. Well, by the time this chyme makes its way all the way through the small intestine and now reaches the first segment of the large intestine, there's nothing left in there but waste material. So it will go from the cecum, this is called the ascending colon, across the abdominal cavity. This is the transverse colon. It will go down the descending colon into this section called the sigmoid colon. Then the waste material will be stored in the rectum, and when it's a convenient time, the waste material will leave the body through the anus. Okay, that's what we call the process of defecation, and defecation is going to rid the body of the material that was stored in the rectum that we call feces. Now, the anus has multiple rings of muscle called sphincters that keep the contents in the rectum until it's convenient for us to rid our body of this waste material. But that's an overview of the digestive system and some of its major structures and the process of ingestion, digestion, absorption, and elimination.